Hello and good afternoon. Welcome everyone to the Golden Triangle University talk. My name is Mitch Patitucci. I'm the Exploration Manager for Teuton Resources. We are a prospect generator and junior mining company in the Golden Triangle. Throughout the presentation, we'll just have a couple forward-looking statements. And our main presentation today, we're going to be going through how Teuton takes an approach at exploring in the Golden Triangle. We'll first talk about our company's location, the geological setting on some of the projects, and we'll look to how previous exploration has taken place on the project, the survey methods used, and how we're going to update those with this year's innovative exploration techniques, tools, and the results that those have given us, and how we plan to follow up some of the exploration targets in the coming years. So here is the Golden Triangle as we see it. Teuton Resources holds numerous exploration properties as well as the interest in the Treaty Creek project. It's 20% interest carried forward. Infrastructure to the region, we have really nice highways that connect back down to Smithers and Terrace, as well as the Northwest Transmission Line, which gives power to the majority of the mines and accessible in the regions for somewhere to be a mine. Specifically for our claims, we have the Grand Duke Road, which is located just east of the Luxor Project. We'll see that it goes within 3.5 kilometers of the eastern edge. Air access to the region, there's the Bob Quinn airstrip. It's a gravel strip just to the north. Here is the Luxor Project, which will be the focus of today's talk. So beginning back in 1982, Teuton Resources first started staking many mineral claims within the Stewart area and has continued to grow and develop its current portfolio to the claim amalgamation it has today, as well as optioned and sold some properties, which we'll get to in just a moment. As the prospect generator model, its goal is to acquire the high quality properties, complete a really nice exploration phase, and see if there's any interest in a joint venture or optioning. One of the interesting photos I found on the side here was Dino, our President and CEO. He's been working the ground since, when it was first staked. Here's an archive photo from 1985, and then this year, still boots on the ground, doing what he loves, trying to find the next big deposit. Teuton was the original staker of the Treaty Creek project, which is host to the Goldstorm deposit, and presently Teuton carries a 20% interest in the Treaty Creek project, which it will continue to work, and it will be responsible for paying, or Tudor will be responsible for paying the exploration costs up until production decision. That deposit does have an indicated mineral resource of 27.87 million ounces of gold equivalent within the 730 million tons at a 1.19 grams per ton gold equivalent. That was updated in 2024, those numbers. So as we said, Teuton holds a really nice portfolio of royalties, as well as the terms and conditions which it options its properties and sells its properties to. The major one being Treaty Creek, and it, on top of the 20% interest carried forward, retains a 0.98% net smelter rate royalty, which Tudor Gold is responsible for paying. There's some other key positioning within the Golden Triangle, such as the King Tut and Tuck claims. Those are now responsible, being paid by Newmont, and some other properties which have been sold to Goldstorm. Specifically, the Luxor Project location, we sit along two very rich metal trends. So just south of the operating Brucejack mine, we see a precious metal trend on the eastern edge, which passes through the Forages area, Cat's Paw, as well as the Tennison porphyry, which that extends down to Scotty Gold and Ascot. And throughout the center of the project area, we have a porphyry deposit trend. So our major pearls, we see Goldstorm, Perfect Storm, the KSM deposits at Seabridge, and we believe that a potential trend extends throughout our project area in the Eskay Rift, Tennison, and Pearson. Geologically, we're within the metal-endowed Kaiba red line theory. So being close to the Stuhini Triassic transition is really where you want to be, and that's where the majority of the copper gold deposits are found within British Columbia. In addition, on the project, we have 7 mineral prospects, and they have the potential to host copper, gold, VMS, and other related mineralization. So for the Luxor project, it's comprised of 8 claim groups. We'll kind of go through a few of them here today, the ones that we've worked recently, the ones we plan on working. The majority of these claims have been staked or have been held since 1984, and continued strategic staking have created the land package that we have currently. Most of the historic exploration has been on the Forages and Tennison areas, testing for copper gold mineralization at Tennison. Several other operators have conducted geochemical, geophysical, and geological surveys in addition to drilling on various other properties while those were on option and have since been returned. Geologically, what we're looking for is the prospective VMS potential, porphyry gold, and epithermal mineralization. We have the Sulphurets thrust fault, which is approximately bisecting the mineral claims. This major fault is related to all of the supergiant copper gold porphyries to the north at Seabridge Gold's KSM property, as well as Treaty Creek. And genetically related to these is the Eskay Rift setting, which we see in green. This represents the infill of the Eskay River formation, and continuation of this leads us to the Eskay Creek deposit to the northwest, which is extremely high-grade gold and past producing. So the eastern and western portions of the Luxor are underlain by the same Triassic Stuhini sedimentary and volcanic rocks, as well as early Jurassic volcanic and sedimentary rocks from the Betty Creek Formation. Either side of the project is being bisected by the Eskay Rift, which was a paleograben which filled with mafic volcanic and clastic sediments that we can see quite easily on the project area. I'll show in just a moment. The younger rift-related rocks are the Eskay River Formation. So at our Big Gold area, our Big Gold property, we can see this physical transition between the mafic tuffs in transitional contact to the well-bedded sedimentary rocks. Our innovative exploration approach throughout the summer was preparing our properties to be worked in the most cost-effective manner, but getting as much data as we can out of each. So preliminary passes with airborne surveys, remote sensing, then followed up by prospecting and sampling, then leading into a detailed geological mapping and ground geophysics. We combine all the historical data that's available. We then use modern technology such as XRF and TerraSpec analyzers. And our end goal is to develop drill targets that are ready to work for future programs. Quite a few geophysical surveys have been conducted on the property throughout the various times operated by various operators. There was a 2005 Aerotem survey over the Grand Duke and Pearson and Leduc area just to the south. There was a Aerotem in 2006 over the Forages, Cat's Paw, Pearson areas, as well as a larger ZTEM survey over the northern half of the project. and several smaller scale surface geophysical programs followed up on targets from exploration efforts. So this year, one of our preliminary goals was to establish where we wanted to work in the field, and we thought of a cost-effective way of doing this was acquiring WorldView 3 remote sensing data. And we first had to figure out what was available and how we can utilize that. So we saw that the eastern side of the Luxor Project had good archived WorldView 3 imagery. So we purchased this data that provided the most cloud-free image, as well as it contained the visible and near infrared wavelengths and shortwave infrared bands. We wanted to test this concept and see how it could apply to future exploration plans and how effective it was at delineating alteration signatures and what those signatures look like from what we know already. So the data was processed and interpreted by Joe Zamudio, who was a PhD, and resulted in several high priority areas on the project. One thing we have to really consider is what the projects looked like in the past and what they presently look like. So the ice extent in the 1970s, when these projects were either first being staked or just being worked, to what it is now, we'll see in areas there's over 500 meters of new bedrock exposure, and this was captured in the satellite imagery. And that also gives us that 500 meter more bedrock exposure to explore that hasn't really been touched or seen. So the WorldView 3 imagery, once processed, we had alteration mapping for kaolinite, alunite, propylite, illite, muscovite, and chlorite, as well as the main iron alterations, hematite, jarosite, and goethite. We'll look at a few examples of how the ice extent was in the past, what it is now, and how the alteration signatures are demonstrated, mainly for the 4Js. So just toggling between the two images, we can see where the ice was to its present day. This WorldView 3 imagery worked very well on our project area, since it is mainly bedrock exposure, not much vegetation, and we have receding ice, which is giving us more exposure. So this is our 4Js area. It has VMS potential as well as some high-grade gold and silver showings. We had historic rock sampling from 2022 and 2023, where up to 29 grams per ton gold were noted. And this area worked really well with the WorldView 3 imagery. We see quite distinctive spectral end members. We have chlorite, clinochlor, illite, muscovite, montmorillonite, all appearing in the spectral bands. And these are comparing to the USGS spectral library. If you continue to manipulate the data from the WorldView 3 imagery, you can kind of tune it and really minimize the false positives in the results you're getting. So here's a slightly different tuned filter that shows the chlorite and muscovite as opposed to the 6 or 7 alteration minerals that we just saw. And I'll just focus on this because we see a pretty unique signature right where our cluster of good gold results were. We're in kind of a chlorite altered region. So we see this and we think, okay, why would this be caused, or what else is driving this chlorite alteration? Is it geological? Is it just a halo of alteration from mineralization? And then we look into what the same geophysical signatures are, what was done there in the past. So in the 4Js area specifically, there have been two main drilling campaigns, one the main zone and the other the FM zone or Frank Mackey zone, which was drilled in the 1990s. The Frank Mackey zone was a bit more gold rich. There was 2.67 grams over 9.84 meters in hole 1. Both of these fall within kind of a unique mag-low signature. It gives a subcircular, a little bit more on the elongate to the northwest, southeast. And then we'll plot in where our gold values are. We're seeing the majority of our good gold values in excess of 0.5 gram, all falling within this same area. The newer 2022-23 rock samples were previously ice covered. So this is only in the last 30 years that these have really receded to a point where we're able to sample there. Even now it's still at the ice edge. For these samples specifically, one really interesting fact is that we had the TerraSpec analyzer, which is able to, it's a modern technology that you can use to sample the rocks to see their hyperspectral results. So using this in conjunction with the WorldView 3 imagery, we can really verify what we're seeing in a rock sample and what the satellite imagery is telling us what the rocks look like as their alteration footprint. So that same response area from the mixed tune match filter, which was chlorite altered, our TerraSpec results are showing us that yes, this is a chlorite rich sample, which also has in excess of 1 gram gold in multiple areas. So following up on this chlorite region seems to be effective. The absorption from the TerraSpec does indicate that the chlorite could have been formed from a low-grade metamorphism rather than a hydrothermal. So that's also interesting to note. For our WorldView 3, it did cover a larger area. So this is going to look at the Tennison area, which has been worked quite extensively with numerous drilling campaigns. We can see the alteration visible from photograph, and on the right-hand side, that was the satellite WorldView 3 image. So over 13,000 meters of drilling and 64 holes have tested the Tennison area. It's delineated as a high-temperature porphyry-style hydrothermal system with associated copper gold. Due to ice cover, it's been mainly restricted to the wedge that you see in the footprint, with strong alteration noted in propylitic, phylitic, and potassic domains. The areas of the strongest alteration were also the areas with the most enhanced copper and gold values. So having this additional WorldView 3 imagery will possibly point us to new areas where we need to explore. Here's some of the drilling highlights. So in hole 8, 103 meters of 0.31 grams per ton gold and 0.42% copper from near surface. The overall trend of the Tennison follows along the same sulfur-etched thrust fault, which genetically connects to the KSM porphyry deposits to the north. The trace is projected to go under the ice from Treaty Creek also, but it projects to go somewhere through the Luxor Project. Therefore, in the Tennison area, it's very likely that some linked faults channel fluids and magmas in this area. So alteration-wise, the WorldView 3 picks up the Tennison porphyry extremely well. You can see it's very strongly picking up the muscovite alteration as well as illite, montremoillinite, and there's some lesser chalcedony. But overall, a strong muscovite presence. So then taking this and looking at the historic mapping, which I think is really well done during the 2013 brigade mapping, we'll see that the moderate to strong quartz sericite pyrite alteration is strongly associated with the muscovite. The weakest quartz sericite pyrite alteration and quartz sericite is mapped primarily to illite, and the potassium silicate, biotite, magnetite alteration appears weakly associated with illite also. So there's just the alteration and how it's been mapped. So kind of that central core of the moderate to strong alteration is the strongest muscovite. And then as you go outwards on the halo, it's lesser, it's more illite. Here with the iron oxides, we pick up the goethite, jarosite, and hematite. We used a spectral angle mapper, which focused on the iron alteration minerals. You see that in the center, goethite is the most abundant, right within the porphyry body, and hematite and jarosite are less abundant on the edges, on the peripheries. So for future exploration, we kind of can use the fact that the Worldview 3 and the alteration mapping on surface confirmed that each other were both effective, and our takeaways can be looking at either iron oxides or more muscovite signatures and how those could be related in areas of new exposure that we haven't field verified, and the varying degrees of quartz sericite pyrite alteration on the Tennison porphyry. So we'll go a little bit further to the south now at the Pearson and Leduc area. So we'll move a little bit further to the south at the Pearson and Leduc area of our Luxor project. Here we have the South Unuk Shear Zone, marking the boundary between the Upper Triassic metavolcanics and metasedimentary rocks to the west on the left-hand side, and the volcanic rocks of the Lower to Middle Jurassic Hazelton to the east. The Pearson Leduc properties are adjacent to the former Grand Duke mine, which was at a time British Columbia's second largest Beshi VMS type deposit after Windy Craggy. And that's just at the bottom left where we see the crown grants, or the crown lots. Limited drilling just on the edge on the now owned Teuton property, the JK zone, confirmed the continuity of the mineralized breccia exposed at surface and magnetite chalcopyrite bearing assemblages. So there are some significant intersections of the results. In hole 9, 2006, 8.04 meters of 0.14 grams per ton gold with 1.5% copper and 3.7 grams silver. The main focus in this area, though, is in 2006, there was an Aerotem anomaly, and this was remodeled by Carrickle Creek in 2013 and interpreted as magnetic susceptibility and conductivity anomalies, which extend onto the Pearson claims. And two significant anomalies are the Northeast EM Anomaly 1, which is seen in yellow, and a second deeper conductor, Northeast EM Anomaly 2, also seen in yellow just to the east. Both are high priority targets and have yet to be drill tested. There was 3 short drill holes that attempted to test this anomaly but didn't reach quite the right target depth, unfortunately. These also correlate well to the 2018 ZTEM anomalies that overlap this area. So we have anomaly Z6 and Z7. They seem to correlate directly with the mag anomalies. Here we've done just some limited prospecting following up on some boulder trains that were found in 2022, where we see some really nice copper, lead, gold, and silver values. But the main source is interpreted to be up ice and could be representing what's shedding off the mountain in this area. In 2017, there was also a really nice zone found with malachite and azurite staining at surface, which connects nearly a kilometer long. The veins and breccias had carried gold values up to 68.7 grams per ton. The alteration in this area may represent a top of a porphyry copper system, but that's not been quite determined yet. So in this area, we do need to utilize more possibly alteration imagery, seeing where iron oxides would appear at surface. More surface sampling is needed before any drilling, and detailed mapping above those anomalies, above the EM and the mag anomalies, as they are interpreted to come to surface or near surface. So we need to explore how those look and what geology is telling us at surface. Now we're at our Eskay Rift area. So recent 2022 discovery in a zone of glacial meltback. The Roman zone is a massive sulfide occurrence at surface. We have silver, copper, lead, zinc, some really nice values there, exposing over 25 meters strike length, semi-massive, massive embedding parallel lenses. The sulfide lenses range between a few centimeters and are semi-continuous across the 25-meter strike length. So since this is a zone of recent ice melt, we need to explore this a little bit further. There's still more and more we'll see every year. So seeing what this looks like as a detailed surface map, alteration, this would probably be a good implementation of a surface IP program to see if there's any good conductive or conductors and resistive sources caused by mineralization or an alteration. And finally, one of our recent discoveries this past summer was one of our properties to the south, the Ram Project, which is just south of Red Mountain deposit and southeast of the Treasure Island workings by Goliath Resources. We found some really nice copper, silver, gold, polymetallic style veins, as well as a copper, gold, moly, porphyry type system. This was discovered near the end of the year just due to prospecting that hadn't really been done since 1994. So taking our historic database, looking in those files, seeing where we have explored, where we haven't explored, and where we should explore was one of the key insights into finding this nice discovery. So in our saw cut zone, we did a saw cut sample of the polymetallic type mineralization, which had 0.7 grams per ton gold. This sample carried 8% copper, quite elevated molybdenum, and nice silver values too. Again, what we're seeing is we're in the right geological setting. We're along the Triassic-Jurassic Stu-Heaney transition, the Khyber Red Line, directly south of the Red Mountain deposit, which could mean that we're in the similar geological continuity, which is really nice to be. We have two zones that we kind of see. So the Mitch zone was the sulfide-rich polymetallic style. That is in well-bedded sediments. There's areas where there's chalcopyrite strainers or veins up to 5 centimeters wide. But we also have some really pyrite-rich, which also seem to have good gold values. The second sample there, 711540, that had 7 grams per ton, 0.11% copper. So we're trying to see how these two systems are genetically relating to each other. They are kind of at different orientations, as opposed to the malachite porphyry zone, where we have really nice fine to medium grain, intermediate porphyry with disseminated and blebby chalcopyrite, malachite, likely molybdenite. Those samples also carried 0.5 gram gold, 1% copper in locations. But we're going to do some more work in the coming season to do some detailed mapping. A really nice ground IP survey would benefit well in this location. Just some takeaways from today. So our systematic approach, kind of going back in time, seeing what has been done, what needs to be done, and how we can most effectively use our exploration expenditure and find new discoveries, continuing to grow and develop our current property portfolio. And go from there. So thank you everyone today. If you did like the presentation and the presentations with the Golden Triangle University, please like and subscribe. Thank you.